All right, we're going to take a look at section 1.4 in your geometry. This one is specifically perimeter and area in a coordinate plane. Let's get started right here. In geometry, you're going to be expected to know what a polygon is and know the names of different polygons. I want to ask you to make sure you memorize the polygons that are up to 12 sides, and then we'll get to that shortly. But what is a polygon? It's a closed plane figure with 3 or more sides, right? It has to have 3 or more sides, or else it's not going to be able to close, right? If I were to take a look at this right here, and I have these two lines, well, that's only 2 sides. I can't make a figure with 2 sides like this, even if I intersect them in all different ways. So you have to have that third side so that you can at least come up with, well, hopefully you know, 3-sided figure is the triangle. So that is a polygon. It's a closed plane figure. Take a look at our next term, a side, which is a line segment that makes up a polygon. And then we have vertex. That is where 2 sides intersect. So if I have these 2 sides right here, and where they intersect, which would be up here, that would be your vertex. Talk about Pentagon, convex, concave coming right up. So once again, if I take a look at this diagram, it says in geometry, a figure that lies in a plane is called a plane figure. Now, right here, if I take a look at this, we have 1, 2, 3, 4, we have 5 sides. So we can go ahead and call this polygon a pentagon. I have highlighted right here, you can name a polygon by listing the vertices in consecutive order. So we could call this polygon A, B, C, D, E, or polygon B, C, D, E, A. You know, hopefully you figure out what I'm talking about there. The names of the polygons, up to 12, that you need to memorize are as follows: triangle, quadrilateral, pentagon, hexagon. For the 7-sided figure, it could either be a heptagon or a septagon. Okay, so both can be used interchangeably. A heptagon might be the more common one, but it all depends on the person's preference. 8-sided figure is an octagon, like an octopus. 9 is nonagon. 10 is decagon. 11, undecagon. And 12 is a dodecagon. Anything after 12, there are names for it, but then we just say n-gon, n being the number. So we say 13-gon. If it's a 100-sided figure, it's 100-gon, and so on. But at least memorize up to the number 12, which is dodecagon. All right, so that right there is absolutely important. Let's move back up right here and talk about these two terms, convex and concave. In a figure that happens to be convex, you will notice that all the vertices happen to be on the outside. So if it's convex right here, I have my triangle, and think about this. If I were to draw a line that extends out, I'll put this in green. Does this line intersect anywhere inside of the plane of the figure? It doesn't. And let's check all 3 sides. No, and no. So what we can say right here is that this triangle is convex. I'll give you this figure next. We have 1, 2, 3, 4, 5. So we have ourselves a pentagon. five-sided figure. So checking and using what I showed you just before, let's take this side right here. If I were to draw a line that goes through that segment, that extends through, you can see that this line goes inside of the polygon. That tells me it is concaved. Okay? As long as it happens one time, then it makes it concave. If you think about a cave, it goes inwards, right? So you may see, maybe that could help you memorize this, the polygon that kind of indents inwards, that's caving in, would look something like what you see there. So there is your convex and concave. So let's take a look at some of our extra practice right here. So we want to classify the polygon by the number of sides, convex, concave. I take a look right here at this side, it looks pretty suspect. If I draw a line that extends out, it goes into the inside of the polygon. So that tells me that this right here is concave. By the number of sides, it has 5 sides, so we have a pentagon, and it's concave. For number 2, if I were to do my tests, right, doesn't go in, doesn't go in, does not extend inwards. So that should tell me right here, this is convex. Looking right here, how many sides? 1, 2, 3, 4, 5, 6, 7, 8. We have octagon. All right, number 3, something that looks kind of like Pac-Man right here. Looking at this side, extending it outwards, it goes on the inside, so that tells me this is concave, and it happens to be another 8 sides. So we got octagon again. And number 4, if you do your tests of extending out the sides, I don't see any that goes inwards, right? That lands inside of the figure. We got to count the sides: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that right there is a dodecagon. Okay? And it is convex. Let's take a look next up at number 5 to find the perimeter and the area of a polygon. Now hopefully you remember that the perimeter is the distance around the outside of a figure. If you don't have that memorized, then make sure you write that down or put that in your notes. Perimeter, the distance around the outside of the figure. So you have to find the length of all of the sides to find the perimeter. Area is the space that the figure takes up or uses. Right? So all of if you were to take a figure, it will be the shaded region inside of it, and that would be considered the area. You are going to have to use the distance formula to help you solve these problems out right here. Let me go ahead and let's draw things out. We'll draw, let me draw an axis right here. Got our y, we have our x. Okay. We have 2, 4. There's 1 point. There's point x. Y is at 0, -2. So down here, there's point y. And then at point z is 2, -2, which happens to be right here. Okay, so we have all of that. If I were to go ahead and connect the points or the vertices together, we have ourselves a right triangle. Now, 2 out of the 3 sides right here, we can figure out pretty easily because of the fact of the matter that they are horizontal and vertical lines. If the lines are vertical and horizontal, then you can just easily count those out. So I know that the distance from y to z is 2. the distance from x to z. We can count that out. 1, 2, 3, 4, 5, 6. Okay? Now, from x to y, that's where we encounter a problem. You can't just count diagonally. So what you can do is end up using the distance formula. So don't forget, d is equal to, we have square root. We got x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So you use the distance formula using the 2 points, and then we can figure out how long that diagonal piece happens to be. So right here, we'll go ahead. Let's plug things in. We have distance is equal to, and we're going to use, remember, x and y. All right, so let's go ahead. I'll put 2 minus 0 quantity squared plus 4 minus negative 2 quantity squared. So let's simplify things out. 2 minus 0 is 2. 2 squared is 4. 4 minus negative 2. Remember, when we're subtracting, we add the opposite. So if we need to, we can change our signs, and that gets us 6. And 6 squared is 36. When we simplify this, we can go ahead and put this as square root of 40. If they ask for an exact answer, we would need to put this in simplest radical form. And so this in simplest radical form would be 2 rad 10. Okay, but that's if we were to put this in simplest radical form and have an exact answer. For now, they don't ask for exact answers, so let's just go ahead and figure out what the perimeter is. To find the perimeter, you're going to add up all the sides. So we can go ahead and put up rad 40 plus 2 plus 6. And then when you solve that out, that will get you your perimeter. I think right now they'll ask you to round to the nearest hundredth. So using your calculator, rounding this to the nearest hundredth, you'll end up with 14.32. And there should be some sort of unit of figure. And since they don't give us feet, inches, or anything like that, we'll go ahead and just say 14.32 units. All right? The last thing we want to find is the area. So in order to find the area, this being a triangle, 1/2 base times height. That is the equation to find the area of a triangle. Simply put, let's try to use nice lines right here that happen to be perpendicular to each other as far as their height is concerned. And so I will go ahead and say that this right here, y to z, is my base, which happens to be 2, and x to z is my height, which is 6. So let's go ahead, I'll substitute all that stuff in. So we got 1/2 base of 2, height of 6, and this right here is equal to 6, and then we have ourselves units squared because we're dealing with area. All right, and there you have it. There is how you find perimeter and area of a polygon. If the polygon happens to have multiple sides, or maybe 4 sides, as you may see in your homework, you need to add up all 4 sides. Okay. If they ask you to find the area of a 4-sided figure, what you may have to do is break the figure up into 2 different parts in order to solve a problem like that. It's all things that you have done in Algebra 1. So for example, if I take a look at number 9 and we look at this figure right here, you can see that this is actually a 4-sided figure, right? If we were to find the distance around the outside. However, if I want to find the area of something like this, there is no equation for that. So what you may have to do, or what you're going to have to do, is you find the area of one triangle, find the area of the second triangle, and add it up all together in order to find the area. All right? Make sure if you have any questions, come to tutorial. I'll see you again later.